Alright, so we are recording, and tonight I'll be uploading that, and it'll be the very first module you'll see. It'll be the recording of today's class. And you'll see down here, here's the schedule and assignment list. And so if we go to the teaching schedule, did the wrong thing. This is the old teaching schedule. So I got to upload the new one. I'll do that right after class. Let me pull up the proper teaching schedule. Alright. So once I post the right one up here, I'd highly recommend that you download this, print it out, and then refer to it daily. It tells you when everything that's due, and it gives you the exam dates, what sections the exam covers throughout the semester. You'll notice right away it says today we're doing 6.1. On Monday there's what's called a 6.1 spot check. And then on Wednesday of next week you turn in 6.1. During week 2 we cover 6.2 and 6.3, but you don't turn those in until the end of week 3. And that's always going to be the case. Whatever your homework you do one week, you don't actually formally have to turn it in until the end of the following week. So there's a delay period with assignments. But then there's this spot check stuff. And this gets confusing for some students. So today we're going to cover 6.1. Tomorrow, before you enter class, at before 5:30, not tomorrow, but next Monday, before 5:30, have uploaded the spot check. Now, in prior semesters, there wasn't a separate upload for that. There is now. So, if we go over here, let's look back at the modules. So, you'll see, if you click on the 6.1 book assignment, it just tells you what problems you need to do in the book. But it also has this button for submitting the assignment. And I highly recommend you get a scanning app. Instead of taking 5 pictures of your homework and then having 5 separate uploads you have to do, if you get a scanning app, it'll be just one upload for those 5 pictures, and it'll come across and be way easier for me to read. It'll just work out much better. And then immediately after 6.1 book assignment, which describes which problems to do, it says spot check of 6.1. Click on that. It doesn't say anything except when it's due, and it has the button submit assignment. So this one, the spot check, you cannot submit late. Regular assignments you can submit late and get some late credit. But spot checks, you either get it or you don't. So by Monday at 5:30, you have to have that uploaded before class starts, and you'll get 3 points if you have at least 75% of the problems completed. Getting some noise from somebody. Let's just take a quick look over here. Anthony, can you mute your microphone? Thank you. Let's go look at, so that's the schedule of the assignment list. The assignments are all listed here one at a time, and they're listed in the assignment list right here. Alright, let's look at the simple syllabus. We go to syllabus for the course. Has a lot of the basic information, the textbook, and how you're going to be graded. Typical grading scale for the school. You see 40% of your grade comes from homework, 40% from exams, 20% from cumulative final exam, and then homework. The objective is for every student to get 10 out of 10 for every homework assignment. So I'm going to assist you in this. When I encounter mistakes in your work, I'll tell you which problems to redo. You'll have 1 week to redo these problems. After such feedback, you don't need to upload the entire assignment, only the problems you're told to redo. So, you do the first section, 6.1. When I'm grading it, I am just going to give you feedback. Instead of saying, you only got 60% of the problems correct, so you got a 60 out of it. Instead, I'm just going to say, these problems you need to redo. Suppose you only have one problem that you need to redo. Then all you've got to do is, within 1 week, upload just that one problem. You don't need to upload the whole assignment over again. I won't accept homework unless it's completed. So if there are undone problems, I'll be stating finish first, and I'll just give you that comment. And then if that's not done within 1 week, well, then you're just going to get a mark down for that. So you won't get a grade assigned to your homework until you've, like if I check and everything I check is right, then I give you the grade right then. But if anything I'm finding is wrong, then I won't give you a grade, but I'll put a comment in there, and then you've got to fix that within a week. And so then hopefully you're going to each be getting 10 out of 10, keeping up with the spot checks, and then making the corrections within a week each time. The way to really shoot yourself in the foot in this class, though, is by getting behind in your work. There's a really big late penalty. First late assignment is you get full credit, but after that, future late assignments you only get 50% credit, half off if you're being late. All right. So then the spot check part here just describes what I've been telling you about spot checks. So if you need to read that again later, it's all right there. Notice it talks towards the end of that, it talks about if you do it all and you do it all correct at the time of the spot check, you don't need to do 2 uploads. You could just upload once into the spot check, and then when the assignment is due, if I don't see anything uploaded for the assignment itself, I'll just look in the spot check, and I'll assume that you mean the spot check to be graded. And so you don't have to do 2 separate uploads if you don't want to. All right. Any questions so far on this? And you can just unmute your microphone and ask, or you can type in a question on chat.
Real quick.
Yes.
Are the problems for the homework from the textbook, are they given in a worksheet, or do we need to have the copy of the textbook to do them?
The problem numbers are available in the modules. Okay, there's a listing of one worksheet that shows you all the problem numbers that you're going to need, and then but yeah, you got to come up with the textbook somehow to be able to see the problems.
Okay.
Okay, I don't have a
I have,
whether it's
sorry.
written work or typed up. So from Rowan, So either way is fine. You can use LaTeX, or if you could use Microsoft Word or something with the equation editor, that's fine, whichever way you want to get that in. Somebody else have a question?
Yeah, so I bought a access code anticipating that the textbook would be available through MyMathLab, but you said earlier that we won't be using MyMathLab, so is the only way to do homework in this class through a physical textbook?
Okay, with MyMathLab, you have access to the entire physical textbook. So, if you're viewing the textbook with MyMathLab, just move to the end of the section and then you see the problem. So you don't need to buy a physical copy of the textbook.
Right, but don't I need like a course access code or something like that to get into it?
Oh, you know what? You will. So let me go, I'll go into, I'll make myself a note here. My note is to create MML course in Calc 2. All right.
Okay, sweet. That's a relief. I was like, dang, I wasted $100.
So you don't need a course access code. What you're going to do is you're going to go in Canvas and hit the My Lab and Mastering button, and then go through that way. And then if you pay, or put in your access code or whatever through there, that will get you into my course. And then all right, so there won't be any problems that I've set up or anything in there, but it'll get you in. Okay, anything else? Any other questions so far?
Where is that My Lab and Mastering in Canvas?
Okay, so it's, let me leave student view. All right, you are, do I see it in my view? I don't see it. Maybe it just hasn't been set up at all. Even the possibility of it, because I didn't tell them that. I'll have to look into that. If I have to do it not through Canvas, I'll let you know next time. Okay. Any other questions? All right. So on the syllabus, we've run through a lot of the main stuff. I just want to make a brief statement that personally, I stand behind the Black Lives Matter movement, and it's about time that we in this country start to address racial injustices that have gone on for ever since this country started. And I think I've covered all the main stuff here. And all right, so the next thing I want you to do now is, first of all, note what group you are in. So, is everybody?
I just wanted to ask if I could choose a preference of one of them.
Yes. So now, a lot of you already know each other, and if you'd like to be in a group with somebody that you know, then that's fine. So then you can pick what group you and somebody could, converse and decide to be in the same group. And then during the break, let me know how we switch the groups, and I'll change these numbers around so that I know who's in what groups. And I'll make sure that each group has at least 3 or 4 people. Right now, every group has either 4 or 5 people. And feel free to swap groups as you want to during the semester, and just let me know. All right, so then let's get over to Discord, and let me tell you what you're going to need to do in here. All right, so first thing is go into your group. Suppose I'm in group 3. Then when I click on group 3, look at how my screen changed. I'm just seeing the chat from group 3. And then when I want to go back to the general chat for the whole class, I have to go to text channels general, and then, so you'll be going back and forth between these two during class. All right, now I'm going to have everybody go into their group and just type 2 letters HI, hi, and it'll tell everybody who you are, and then also, you need to go to every group that you are not in, and you need to mute it, because you will get notifications when anybody in your group sends a message, and you're going to be sending messages to each other throughout class, but you don't want to be notified when anybody in any group is sending a message. You really don't want that. So what I want you to do is, let's go to, let's say, group 1. Right click on it, mute channel until I turn it back on. And so do that for all of the groups except for the one group that you are in. I'm going to do it for all the groups. Okay, so hopefully you all have muted every group except for the one group that you are in. And now there's a couple things with the groups. First of all, I'm going to have you all take a minute now and type into your group channel an introduction of yourself. Talk about why you're in school, where you're going, what kind of degree, what kind of program, or so on. And I'm going to give you about a minute or so to introduce yourselves within your group. So go ahead and do that. Okay, 10 more seconds to wrap up. If you're still typing away. Okay, the next thing is each group is going to have a spokesman for the day. And we're going to go in alphabetical order by first name. So if there's an Amy in my group, she would probably be the first one. She would be the spokesman today. So when I give you group time to work on a problem, and then I say, all right, group 3, what did you get? Then Amy is going to come on, because she's a spokesperson today, and she's going to say, this is the answer that we got. And then the next time that we meet, next Monday, we'll rotate, and so if there's a Brian in the group, Brian would be the spokesman on Monday, and we'd rotate every day who the spokesman for each group is. And also, there needs to be a group leader for each group. The group leader is going to be tasked with, the main thing is, if I call on group 4 and the spokesman for the day has stepped away from their computer, or they're having computer problems, can't get their microphone to work, or they're a parent with children at home and one of the kids just had to, needed attention, and so they've stepped away, that kind of stuff will happen. So the group leader will step in and then answer for the group whenever that group is coming up blank. Okay? The group leader will also, at the beginning of each class, confirm who is the spokesperson. So group leaders, you're going to try to keep track of who was the spokesperson last time, so then you rotate it to the next person by alphabetical order by first name. If you forget, then you might just pick somebody at random and then start over again. And the third thing, and it hasn't happened much, but it could happen, is if I am lecturing and we get lost. So if you're lost while I'm doing a lecture, one of the things you should do is go to your group chat and say, I'm lost. And then the group leader, if the group leader agrees, the group leader is lost as well, or the group leader sees that 2 or more people have said, I'm lost, then it's the group leader's responsibility to interrupt me by voice and say, Robert, stop where you are, we got people that are lost. And then I'll stop where I am and we'll address the issue and so on. And I'm going to give you a little later today, I'm going to have each group, somebody's going to have to become the group leader in each group. And if nobody wants to, you'll have to figure out some kind of random way or something of assigning it. But every group's going to have a group leader before the end of the day today.
Mr. Shankin, forgive me for asking, but how do I find my group again?
Okay, let me go back to that screen right here. There is your group. Everybody see it?
Yep.
So,
I don't see it.
was up there. Let me go back to it. Everybody see it now? You got your group number? Just takes one quick glance at it to see what number you're in, and that's your group for the semester. And again, you can swap them out. You can go to a different group. If you have some friends that you want to be with or something like that, just let me know. Alright. And, alright, we are about to start, and I'm going to start covering some math and stuff. Any questions before I go into that stuff, though? Does everybody know what group they're in? You've entered something into your group so your group knows who you are. All right. Now, one other thing is you're going to get an assignment today, 6.1. And in 6.1, there is there is one problem number 40, that I'm going to have you check with your group members before we meet next time to see that you agree on your answers on number 40. And so, and you have all the flexibility you want with that. Like if there's 4 people in your group and you can't find a time that all 4 of you are going to get together, and you can get together by phone, or you can come into Discord, you could Zoom to get together, whatever. But you could also break up in groups of 2. So 2 of you will get together and just check your answers, and the other 2 will get together at a different time. So before we go off today, make sure that you know how you're going to check problem number 40 with your group members. And we'll do that for the first number of assignments. I'll give you a problem each time that I want you to check with your group members outside of class. All right, so we're going to go over here. This is OneNote. And in one of the announcements in Canvas, it talked about downloading Microsoft Office, that you have free access. You can download it for free by being a SFCC student. And then OneNote is an application. Once you download the Office, run OneNote, and then when you click on that link that's in my announcement, you'll have access to this throughout the semester. So all the notes that I give will wind up coming in here one way or another into OneNote. And most students, when I've asked, they still take notes because it's a way to stay engaged and to have kind of the essential stuff right there in front of them. But if you run into any decisions where it's like, do I continue taking notes or do I listen so that I really understand what's going on? Well, you can always choose to just listen and stop taking notes if taking notes is ever a problem and you're ever falling behind, because you can always go back and look at the OneNotes. You see on the far right it says 6.1 velocity change. After the next lesson there'll be a 6.2 tab right there, and we'll have this all filled up by the end of the semester. The notes for everything. All right, so we're going to start with a practice quiz. And so all I want you to do right now is numbers 1 and 2. So go ahead and work those out. This is, you might have to knock off a little bit of rust if you haven't done calculus in a little while here. We'll be using this skill in 6.1, this integration stuff, so I just wanted to make sure that we're all up to speed with this. So I'm going to give everybody a minute now to do numbers 1 and 2. All right. Does anybody need more time? Just interject with voice if you need some more time. All right.
Yes, please.
Okay, let me give a little more time.
Yeah.
All right, let's go to number 1. So we need an antiderivative of x cubed, which is x to the 4th over 4. I could put it x to the 4th over 4, or I could do it like this. And then there's plus a constant right here. Now, the next one, so you can always check your work on this. You take the derivative of this, and it should get you back to this. And the 4 times the 1/4, you cancel out, and you get x cubed. The derivative of any constant is 0, so you get back to this. So, number 2, we need an antiderivative of this. It's the same as what we had before. We need to evaluate it from x equals 0 to x equals 2. And we plug in the top number first. And this is kind of why I like to have the constant factored out. So I only have to substitute it into the variable portion. And so then it's 2 to the 4th minus 0 to the 4th. And 2 to the 4th is 16. 16 divided by 4 is 4. Right here. Alright. So let's go to number 3. Now, let me give you a minute to do number 3. Okay, I'm going to stop you now. With number 3, we can't do this without what we call a u substitution. We let u equal 2x minus 7. Then if we take du dx, we get 2. If you multiply both sides by dx, du equals 2 dx. We come back and we look at this. It's just a dx over here. So I want to solve this thing to match that. So I divide both sides by 2. dx equals 1/2 du. Now, this allows me to rewrite the integral without using x at all. The integral u to the 5th and then for dx I'm going to replace it with 1/2 du, but the constant gets to come out front. Now, We had to do this because this was not just x to the fifth, like this one was x to the cube. This was a function of x to the fifth. And you have a function of x to the fifth. If you just tried to integrate it like we were doing over here, we'd get it wrong. We can only integrate nice simple things like u to the fifth du. Now, u to the fifth du becomes u to the sixth over 6. I'm going to put the 1/6 up here, and then u to the sixth. And then since it's an indefinite integral, plus a constant, so this becomes 1/12 u to the sixth plus c. And I'd leave that as my final answer, except, hey, the original problem didn't have any u's in it. So this would be total bafflement to somebody looking on. So we have to come back to x's. So it's 1/12. U is 2x minus 7 to the sixth plus a constant c. That's my final answer. And I can also check my work. If I take the derivative of this, I should get back to this. And 6 times 1/12 is 1/2. This to the fifth. Then chain rule, derivative of that gives me 2. And the 2 and the 1/2 cancel out, so I would just get this. The derivative of the constant is 0. So this matches. Alright, so what I want you to do now is give me some feedback. Go into the Discord and in the chat portion, tell me, you might say something like, well, I was okay with number 1, starting with number 2, I was not good, or I'm really rusty with all of this stuff. Just everybody give me some kind of feedback. Need to review this more is a very important comment if you need that. If you didn't really need the review, let me know that too. Okay. Alright, let's go back to OneNote. Alright, so number 4 is the same problem as we just did in number 3, except it's a definite integral. So, go ahead and do number 4. Alright, I'm going to stop you now, and let's do this. We're going to do it the same way we did the other one. U is 2x minus 7. Du dx equals 2. So I have du is 2 dx, or dx equals 1/2 du. Now, that allows me to come back up here and rewrite. Now, I'm going to also put in, these are x values. X equals 2 to x equals 4. And I'm going to rewrite this as an integral without using x anymore. And this is going to be u to the 5th, and then 1/2 du will replace the x. Now there's two ways I can proceed. I can proceed and still keep it x equals 2. That's the slow way. Now, let me show you the better way, the fast way, and then I'll show you the slow way as well. But the better way is to change these right now to u values. When x equals 2, just plug in 2 right here. You get 4 minus 7, which is -3. When x is equal to 4, plug that in, you get 8 minus 7, u equals 1. Then you're going to get 1/2 u to the 6th over 6, but the over 6 I'll put in like this. I'll take everything but the constants and I'll evaluate that from -3 to 1. So this is going to be 1/12, and then you do the upper one first, 1 to the 6th minus -3 to the 6th. And then you got 1/12 times 1 minus, and -3 to the 6th is some big number, and then you punch that on your calculator, and then you get your final answer. Alright, now that's the efficient way to do it. You could also do it inefficiently. Let me insert a little more space here. The inefficient way to do this one is, let's take yet a new color here, would be at this point here. Instead of when I rewrote it with u's, I get u to the 5th, 1/2 du. I could have kept them as x's. If you don't write x equal, but you just write 2 to 4, it will imply that it's u's that you're talking about, and you'll probably substitute it in and you'll get it wrong. All right? But if you put in x equal, that's okay. You then would get, you'd still wind up getting 1/12 u to the 6th evaluated from x equals 2 to x equals 4. And then this would become 1/12, but now you can't substitute x in for u, but you could go back and put u as 2x minus 7 to the 6th from x equals 2 to x equals 4. And then, substituting this in, you're getting 1/12. When I substitute the 4 in, I'm going to get 1 to the 6th. When I substitute the 2 in, I get -3 to the 6th. Notice I'm getting exactly the same answer, but it takes a little longer. That's why I'll do this first method of what I have in red when I have a choice. Okay, and we are now at the time for a break. The general format of this class will be, we'll run for approximately an hour from 5:30 to 6:30. We'll take a 15-minute break, and then from approximately 5:45 to 6:45 from 6:45 to 7:45 the second hour. And so we will start again. It is now 6:35. We'll start again at 6:50. And just want to write that in. Start again at 6:50. I'll step away from my computer and I'll mute into Discord. But quick thing, before you take off for your break, settle on who is going to be the group leader. You'll need a volunteer, or you'll need some way to choose somebody or something randomly, whatever. And make sure every group has a group leader. And if anybody's switched groups, just let me know. I'll keep track of that, and I'll just kind of check to make sure each group's got at least a few people in it. All right. I'll see you in a little bit. Okay. So Alma Lopez. In group 7, great. I can give you ideas. Let me look. Okay, welcome back. We'll start up again. And so there's only one more practice quiz problem that I want to go over, and I'm going to go over it very quickly here. It says, which of these two is nearly impossible to integrate with a U substitution, A or B? And if you look at them, the difference is B has this extra X out here, and the A does not. And so the answer is A, is you can't do that. Because if you tried A with U being x squared plus 5, then du dx would be the 2x, and then du would be 2x dx, and you're going to get this extra x dx that isn't in here. It allows you to do this one, the U substitution, but not this one. So the general strategy with the U substitution is you have to look for two functions that one of them is the derivative of the other. There isn't in here, but here there is. This function and this function. And the one that's the higher power is going to be the U, and then the du, that'll show up in the du. And it can be off by a constant, and that's all. Alright, so we're going to go into, there's a problem we're going to skip there in the practice quiz because of lack of time. We're going to go into 6.1 right now. And 6.1, velocity and net change, that's the title. And the objectives in this lesson are, and I don't often write down what the objectives are, but this, it might seem, because there's so much here, that you get lost and you wonder what was the real point of today, and this is the point. Understand what a position function, S of t, might represent. To refresh yourself that the velocity is a derivative of a position function. The displacement of an object between A and B is the difference in the S's. So if S is a position function, then when you take the difference between your position at one time, difference the other time, that's called the displacement. And that's also the integral of the velocity. Why is it the integral of the velocity? It's the integral of the velocity because velocity is s prime of t. And you take an antiderivative of s prime, which is s, evaluate it here, and evaluate it at the lower limit, and you subtract. So thus, the displacement is going to be the integral of the velocity. And the distance traveled is the same expression, except there's absolute value around the velocity. And we will experience this today, and hopefully you'll understand all this. And those are the objectives for today. And so we're going to start with a problem. And the problem is, suppose the position function of an object, s of t, is equal to sine of t, where t is in seconds. How is the object moving? And this might be a little trickier than it at first appears. So what I'm going to have you do is go into your group in Discord and discuss this, and then I'm going to give you a minute, and then I'm going to call on a group. Every group should have a group leader and a spokesman for today. And so let me give you a minute with this. 30 seconds more. So, let me ask group 2, and always throughout the semester, whenever I ask you or your group, you can always say pass for whatever reason you want. You don't have to answer. But group 2, I'm going to ask you, is this correct or not? The object is moving like this. And it keeps doing this over and over and over again. Group 2, do you agree or disagree?
I don't know if Avinash, he's the spokesman, but I don't know if he has a mic, but I agree as the group leader.
Okay. Oh, that's a very good question. Let me come back to Discord. Is there anybody who does not have a microphone? Go ahead and enter in the chat at the bottom if you don't have a microphone. So, Nehemiah, you do not have a mic. So you will never be a group spokesman as long as you don't have a mic. Okay? We'll rotate in your group around you. Sorry about that. Yes.
Hi, sorry, can you hear me now?
Yes, I can hear you.
Oh, okay, yeah, sorry, I just had it off. Yeah, I'm the spokesperson for group 2. Sorry about that.
Okay, great.
But yeah, we agree with it.
You agree that
Yes.
the object is moving like this, and it just keeps cycling back and forth like this. All right. So, if I was in your position in this class, I probably would have answered the same way, that this is how the object is moving. But it turns out that this is wrong. The object is not moving like this, and let me explain. Suppose we have, you drop something from a tall building. Here's a tall building, and you drop a small metal ball. And the flight path of the ball is like this. It just goes straight down. But when we would draw this, time and height of the ball. At time 0, the height of the ball is right here. What we would see is something like this. It moves very slowly when you first drop it. It moves faster and faster as it falls. And it would be a parabolic shape right here when you draw it. So this position function could be the vertical position, and then it would be a height like this. So position functions deal with time is the actual flight path of the ball is just straight down. But we imagine it stretching out when we conceptualize it with time as the horizontal axis over here. And it's really handy to see that, because if you just look at it here, you can't tell that it's going faster and faster as it's falling down. From here you can. The slopes of the line get steeper and steeper as you move to the right. So what's going on here when you have a position function is the graph you get from that is not the flight path. Actually, how is the object moving? Probably, it could be a number of different things, how the thing is moving, but it would, let me come back to my notes. This could be measuring the height of a dot painted on a wheel. Suppose you had a wheel and you put a dot right here at a height of 0. And then as this wheel rotates, it goes up and then back down to here, and it goes, and it cycles through all these different heights. And if you plotted the heights over time, the height of this red dot over time, it could be, so this could be could be the height of red dot as the wheel rotates. It could be the height of a object on a spring. Suppose you have a spring and you have some object here. And then that's its rest position. You pull the spring up to a height of 1 up here, and then you let it go. Then the spring, the center of this object, would rotate down. Maybe you'd start the clock when the object gets to here, so it would start at height 0, and then maybe you'd pull it downward and then release it, and it would bounce up at first to be like this, and then it would bounce back and forth. Now, this would be an idealized spring. With a real spring, there's friction, and so the next time it did it, it wouldn't go quite up to a height of 1 and so on. But an idealized spring with no friction, it would be the height of this thing oscillating back and forth, but then when we graph it, it looks like this. We stretch it out. So that's a fundamental thing when we're dealing with position functions. Understand what a position function might represent. The graph of a position function thing doesn't necessarily represent the path of travel, because we have this imaginary thing that we can do with time that we have to be aware of. All right, let's go to the next problem. Let's compare displacement to distance traveled. All right, now we're getting rain over here, so I imagine you're getting some background rain noises. Can everybody hear me okay though still?
Yeah.
I can hear you fine.
Great. So compare displacement to distance traveled. So here's a graph. You can see at time 0, s is 2. At time 1, your height is 1. At 2, you're 2. At 3, you're 3. Find, for t is from 0 to 3, find the displacement and the distance traveled for this situation. So I want you to work on this, first of all, individually. So give it a minute or so working on it by yourself. And then when I give you the go-ahead, I want you to enter your answers for displacement and distance traveled into your group chat. And then I want you to discuss that and see if you can come to consensus on what the displacement and the distance traveled is in this case. We just have thumbed over. So don't type your answer into your group chat yet. Just keep working it on your own. Okay, go ahead and go to your group chats, enter your answers, and discuss it. I'll call on a group in a minute. Okay, 20 seconds more. All right, group 6. What do you have for the displacement and distance traveled?
We got 1 displacement and 3 distance.
So the displacement you said was 1,
Yep,
and the distance was, you said,
3.
3. And tell me how you came up with this displacement of 1.
Well, we're doing displacement as just the difference between the origin and where you end, beginning and ending of the range.
All right.
And yeah,
So it's really the position at the end point, 3, minus the position when you started. And your position at the end was 3, and your position at the beginning was 2, and your displacement was 1. Alright, so we can think of this for a moment like this. Suppose you were walking. You were 2 miles away from home. And then in 1 hour, you had walked back towards home and you were only 1 mile from home. And then over the next couple hours, you went to where you were 3 miles from home. But the displacement says, well, I don't care what happened in between. You started 2 miles from home, you ended 3 miles from home. It's always your end position. And then notice, if you reverse these, you're going to get it wrong. It's not the beginning position minus the end. It's always where you end up. End position, subtract initial position. Always for displacement. And we just want to see how much you moved from the beginning to the end. All right. How did you get 3 for your distance traveled? Group 6.
so 3 is just.
You know what? If every time you as a spokesman talk, first time you talk for the day, if you just briefly say what your name is, just say what.
Okay. Okay. This is Ethan. Hi. We all got 3 as our distance, just because that's the total distance traveled. 0 plus 1, or 1 minus 0 plus 3 minus 1.
Ah, okay. So Jonathan, then, what's the difference between displacement and distance traveled?
I guess displacement just being the distance between the where you started and where you began, regardless of whether you cross back and forth, and total distance traveled being the absolute value.
Ah, gotcha. Now, distance traveled, you referred to absolute value with these objectives way back here, the distance traveled. Now, let's look at this. The displacement is like an area under a curve, and the distance traveled is the absolute area under a curve with absolute value. Is that the case right here? Now, the area under the curve is a lot bigger than 1. And you take the absolute value of these functions, and you're still going to get, since they're all above the x-axis, the absolute value isn't going to change anything. If we use this formula up here, we would get the same answer for both, and it doesn't seem to make sense over here. Now, how come my formula doesn't make sense with this problem? The answer is, these formulas only work if you started with a velocity. It's the area under the curve of a velocity function, and it's the integral of the absolute value of the velocity. This was not a velocity. This is a position function. This wasn't how fast you were going. This is just where you were. And so it has nothing to do with areas, and has nothing to do really with, now in an abstract way it does have to do with absolute value. As you come down from here to here, you can see you traveled 1 mile, and then you traveled 2 more miles. And you'd kind of think of it as these vertical distances over here. Okay, so now let's go to the next one. Suppose S of t is as shown in this picture. And the first one, find the displacement of the object from t between 0 and 4. I'll give you a moment for that. And then part B is asking how might the object have been moving. And you can make a little bit of a story. You can remember, like the other one, it could have been a wheel rotating, could have been a spring going up and down. It can be lots of different things. So you're just coming up with one possibility for how the object might have been moving. There'll be more than one answer for that. So start by doing this on your own, and then at my cue I'm going to have you enter your answers with your group. All right, go ahead and put your answers in your group channels and discuss that. Okay, 30 seconds more. Okay, group one. What was the displacement of the object?
Can you hear me?
Yes.
Sorry. This is Jerry. The displacement is -1.
How'd you come up with that?
With the same function that you put the end point minus initial point,
Okay, so it's
which is
-1 minus 0, which is -1. All right, I agree. Looks good. All right, now, how might the object have been moving, Jerry?
I just took a wild guess.
Yes, that's what we need, wild guesses.
Yeah, but I think it's moving upward and then downward. As it you threw a ball up the air and then it came down.
Great,
I think
you even have a story, a ball going up. How far did it go up when you threw it up?
I went to
2. How far did it go down?
-1.
-1. Very good. All right. So now that's a great description, and I'm glad you took a wild guess. Wild guesses will be highly encouraged in this class. You'll get a lot more out of it this class if you keep taking guesses. And now also what could have been the case, and it's very often the case, is we decide one direction is positive. It might be to the right instead of up. So right might be the positive direction, and so something went to the right 2 units, and then it stopped very briefly, and then it turned around and went back to the left 3 units. And it went to the right quicker though, because it went 2 units in 1 second. And then it went to the left not quite as quickly, because it took 3 seconds to go 3 units to the left. All right, so we have a couple different stories about how might the object have been moving. All right, and then let me just type something in here real quick. How might the object have been moving? We might say up 2 units, then down 3 units. Okay. What distance did the object travel in the interval from 0 to 4? And then part D, for a position function, moving right versus left or up versus down, explain displacement and distance traveled. So 2 parts now. C, what distance did the object travel? And then come up with your own definition for, with a position function, what does displacement mean and what does distance traveled mean? So everybody get their own answers for these. Spend a minute doing that, and then I'll give you the cue, and then you'll type these in your groups.
we supposed to do D as well?
Yeah, C and D.
Okay, because I can't see D.
Okay.
Yes, thank you.
There we go. Okay, enter your answers in with your groups. I'll call on a group in a minute.
Hey, Professor Shankin, can you go back to the graph real quick?
You bet.
All right, thank you.
You're welcome. All right, let me have you stop. Group 7. What distance did the object travel?
Can you hear me?
Yes, we can hear you.
Okay. Hi, I'm Alma, and the total distance that we got was 5.
5. How'd you get that?
We added 2 and 3, so
Very good.
just yeah.
You went 2 up and then the 3 down, as if all directions are positive directions. All right. And Alma, what do you have for explaining displacement and explaining distance traveled?
So displacement is the change in position. So the difference between the endpoints. And then
Okay, we'll say final position, subtract initial position. Which is change in position. Okay? Distance traveled?
that's the total distance traveled regardless of the direction. So it doesn't take into consideration the path traveled.
As if all directions are the positive direction. And that's right. There's gonna be cancellation in displacement, possibly, but never in distance travel. Okay. All right. And on E and F, I'm just going to go over these real quick. For what intervals of time is the object moving in the positive direction? Now, to answer that, we come back to the graph. When it's moving in the positive direction, you can technically get this by just looking at the slopes. When the slopes are positive, you're moving in a positive direction. When the slope is 0, you're not moving at all. So at t = 1, you're actually at rest for just a moment. You're turning around. You went up, maybe, and then you're going down, but the ball would hold still for just a moment right there. When the slopes are negative, that's when you're moving in the negative direction. So you can answer this in terms of slope. But it also makes sense just looking at it. Hey, you're going up, and then you're going down, and we decide that the up direction is positive, the down direction is negative. So this one, for what intervals of time are you moving in the positive direction? You'd say from 0 to 1. 0 less than t less than 1. Okay. Is the area under the curve of S equal to its displacement? We talked about that a little while ago. This is not going to be the case. Area under curves of velocity functions will give you displacement. But when it's a position function, the area under the curve doesn't give you anything useful. All right, so we'll say no. Let's come down to another situation. Now we have a velocity function. It's kind of similar to this one, similar points. At 1, you're up at a height of 2, but this one, instead of a curve, it's straight line segments. All right, so similar questions. But it's very different now because this isn't a position function, it's a velocity function. So, for what time intervals is the object moving in the positive direction? So let me give everybody a minute to think about this. And go ahead and go to your group and enter in your answers. And briefly discuss that. Okay, group 3. For what intervals of time is the object moving in the positive direction?
We said it's in 0 and 1.
Between 0 and 1, the object is moving in the positive direction. Now, I would agree with that answer if this was a position function, because the object's going up to 2 and then falling. But it's not a position function. This is a velocity function. So, at time 2 seconds, the velocity is positive 1, meaning it's still moving, like if it's going uphill, like if it's a ball that's going up, the ball is still rising at t equal 2 because the velocity is positive. When you finally get to t equal 3, the velocity is 0, and then the velocities become negative over here. So, this answer that you gave is probably exactly the same answer I would give my first time. I remember first looking at this stuff and making exactly that same kind of mistake. We just have to treat this very differently when it's a velocity function. So, at what time intervals is the object moving in the positive direction? It's from t between 0 and 3, not between 0 and 1. Positive this whole time, going up. Then, for what time intervals is the object moving in the negative direction? I'll answer that. That's when t is between 3 and 4.
Okay.
Okay, and then next is asking, describe the motion of the particle in the first second, from seconds 1 to 3, and then from seconds 3 to 4. So, let me give you a minute to think about that individually. Maybe you could tell a story about what's happening with this particle in each of these time intervals. Okay, enter your answers in your group chats. Briefly discuss. Okay, we hit stop. Group 4. What's the motion of the particle in the first second?
It accelerates at a constant rate and suddenly decelerates at a lower constant rate.
Did it decelerate in that first second?
Yes. Or previous to that second, sorry.
All right. I like the way that you said it's accelerating. So in the first second, let's say this is something that's going up. It could be going to the right. Right could be the positive. It's going up. But it's accelerating. It doesn't decelerate within the first second, though. In that first second, it's just going up the whole time. All right. Now, what's your name?
J.
Jay? Okay. From 1 second to 3 seconds, what's the motion of the particle?
Negative?
So is it going down?
Oh, I'm sorry, it's positive?
So is it going up?
Yes.
All right, going up. And is it going up the same way it was going up in the first second?
No.
What else? What's changed?
It's going slower.
Yes, so it's decelerating. It's going slower and slower. Maybe there's 2 C's. I'm not sure. In decelerating. So it's still going up, but something happened. It's like, you know, you had, this might be a rocket ship. That in the first second it was going up, and then something happened with its motor, and it's not doing so good. And it's still going up, but it's going slower and slower. And then what happens between seconds 3 and 4, Jay?
I'm sorry, we didn't discuss that far.
Okay. All right. So from 3 to 4, you did pretty good by getting this far. From 3 to 4, well, what happened at 3? Well, its velocity is 0. What does it mean when a velocity is 0? It means it's standing still. And then after that, it is negative velocity. So if up was a positive direction, it's then going down. So it's going down. Now, instead of accelerating or decelerating, I'm going to say faster and faster. Because accelerating or decelerating gets tricky when you're negative. If you're, for instance, if you are a negative velocity and getting to be less of a negative velocity, we call that accelerating. So you're not actually going faster, but remember the positive direction is up, so it kind of gets a little bit tricky in the negative. But we're not going to focus on that. We're going to focus on, when it's easy to understand accelerating and decelerating. And we can use like faster and faster when it's got negative, when we're in the negatives. All right, so together, let's find the displacement of the object from 0 to 4, 1 second at a time. And we'll notice how we're going to get areas when we do this. All right, so the displacement of the object from 0 to 4, 1 second at a time. In the first second, what's my displacement? I can't say it's 2 minus 0 because this is not a position function. This is just velocity functions. So how am I going to get the displacement in the first second? Well, since I use straight lines here, I can easily compute my average velocity. Now my average velocity in this first second was, I started at 0 velocity, I ended at 2 velocity, so halfway in between was 1, that's the average velocity. Average velocity is right there. And so I'm averaging 1, let's say it's meter per second. We didn't have units in here. If I'm averaging 1 meter per second for 1 second, then I must be going 1 meter. I find the area underneath this curve. When I find the area inside this green rectangle, it's the same as the area underneath the red curve right there. This extra area here would fill in the missing area right over here. This is my really super quick and efficient way of finding the area of a figure, is take the average height and multiply it by the width, and I'll get area. So my displacement in the first second was, let's say, 1 meter. Over the second, from 1 to 2, well, I ended up at 1. My initial velocity was 2, maybe meters per second. So my average velocity was halfway between 1 and 2, 1.5. Now when I multiply that by the width of this rectangle, I'm going to get 1.5 meters. when you have a velocity function, the area under the curve is going to correspond to displacement over here. Okay. Now, we're actually still positive displacement over here, because remember, we're still going up, but we're just decelerating now. Now, from 2 to 3, I started at 1 meter per second, ended at 0, so my average speed was 1/2. And so multiply that by the width, and I get 0.5 meters. If this was in meters, yeah, I did have it meters per second. Okay, and then this last one, I started at 0 meters per second, ended at -1 meters per second. So my average velocity was -1/2 meters per second, and the area here is -0.5 meters. Now these two would cancel each other out, and I would get 2 meters would be my displacement. Now, if I had asked what was the distance traveled, the only thing different is I would have taken the absolute value of this, so that this, instead of going underneath the x-axis, would have come up, and then I would have gotten positive 0.5 meter. So these two wouldn't cancel out. I would get 3 if I'd asked the distance traveled. Distance traveled is 3 meters. And using simple geometry, we could find this, and that would be the distance traveled, and that would be just sending this part up and getting a positive 0.5.
Wait, Mr. Shankin,
Yes.
for the displacement, wouldn't it be 2.5 and then the distance would be 3.5?
Thank you, thank you, thank you. That is correct. .5 meters, because it was 1 and 1.5, and the last two canceled each other out. And then 2.5, 3.5. Thank you. And so the formulas for displacement and distance traveled, they were already in the objectives. And we've run out of time, so if we went back up to the objectives, you see the displacement is this formula, and the distance traveled is this formula right here. And all right, so there's a little bit more that I wanted to get to, and you can read about this in the notes. You have access to OneNote. I'll leave this on the screen as well. And your homework is 6.1. Those specific problems that are laid out, you can look in the homework sheet for the semester, or you can get into the modules. And before you come to class, so today is Wednesday, before Monday at 5:30, have uploaded at least 75% of 6.1 so that you're in a position to ask good questions. And then you'll get credit for the spot check. And we'll stop here. I'll see you next week. If you have any questions or anything you need to discuss with me, I'll hang out for a little while here. Oh, I have to remember, stop the video.